Day 45, page 935, problem 21. Here's our first really challenge problem. The geometry of the problem says the original image, which I have as a black arrow, which is the clock, is 100 centimeters from the original converging lens. It has to be a converging positive lens. It says that, but it's also on the screen. But then when you insert the diverging lens, 90 centimeters from the first lens, the image, which I've drawn now as blue, the final image, moves 20 centimeters further out. So I know since the Q there, the image distance, is greater than the object's distance by double, I know that the ratio or the magnifying power here right now at the final step is doubled. In other words, the blue image is twice as big as the black image. The black image never really is forming now. It's being changed. It would have been there if there was just the single lens, but that black image is no longer appearing, just the blue image, but it's twice as far, so it's twice as big because of the equation. I'll write it down. M equals negative S sub I over S sub O. So if the image distance is twice as far as the object distance, you have a twice as large image. But here's where it also gets a little tricky. If we go to the lens equation, 1 over f sub 2, which we're looking for, let's just start writing that out. 1 over f sub 2 equals 1 over the object distance. Now, we have, in all general cases, the object distance being positive because we're working left to right. Our convention is if our object is to the left of the lens, we have positive object distance. But now we have an object, the little black arrow, which is to the right of our diverging lens. So by our convention, this is one of those cases where you're going to have a negative object distance, and that's going to be negative 10 centimeters plus, and once again a little bit backwards here, the image here is on the right-hand side of that lens, so its image distance is positive instead of negative. So it's kind of opposite what we normally have with lenses because it's a double lens system. And that distance there is 20 centimeters. So if you crunch the numbers here, you get f sub 2 is negative 20 centimeters. There's a focal length of negative 20. All right, so that's kind of tricky. Now it also asks you how big is the final image. Well, okay, let's go back to the final magnification here. M sub 2, well, we know it's going to be 2 because it's going to be the opposite of the image distance, negative S sub I, so negative 20 over negative 10. So M sub 2 is simply 2 times bigger than, it's a multiplier of 2 times the first image. And in the first image, does it say, well, we've got to go back here. Actually, we don't need to go back very far. It just says the first image is 20 centimeters in diameter, so the second image will be 40 centimeters in diameter. So the answer is 40 centimeters because it told us how big the first image was.